Hello everyone, welcome back. My name is Dinakar and I am a product manager in the Azure data team in Microsoft. This is session 2 of mission critical capabilities from Azure Arc SQL MI. If you have not watched the session 1, I highly recommend watching it as we discussed a lot of fundamental concepts and the different capabilities and a lot of things in that session 1. So this will be a continuation of that. In terms of agenda, in session 1, we covered what is Azure Arc, the various customer scenarios that we are attempting to solve. We discussed the different models of Azure Arc, things like Azure Arc enabled infrastructure, Azure Arc enabled services, and under the services, we went in depth into Azure Arc data services. We also went over the various past benefits that are included in Arc data services, things like easy provisioning, deprovisioning, elastic scalability, built-in high availability, built-in disaster recovery, built-in automatic backups, built-in monitoring, logging, all these things, right? And then we also discussed the architecture of Arc data services, which includes the Kubernetes operator, that is the Arc data controller. We went to Azure portal and deployed a data controller. Then we went into one of the Arc data services, which is the SQL MI. We also did a SQL MI deployment through Azure portal. We covered the different service tiers. We did a high-level overview of the business continuity features, and then we did the TCO overview, and then finally the roadmap. In session 2, we will go into in-depth into each of these as benefits or business continuity features, things like HA, automatic backups, instance failover groups, monitoring, security updates, and we'll do plenty of demos for each of these. We will also cover security and upgrades in this session, and then we will wrap it up with the roadmap of the offering. Again, just a reminder, if you haven't watched the session 1, I highly recommend doing that first to understand the concepts before deep diving into the demos. Okay, so let's move on. The first feature we will talk about today is the high availability for both general purpose and business critical service tiers. And we will start with general purpose. Remember in session 1, we discussed there are two service tiers, general purpose and business critical. And we said the general purpose is equivalent to the standard edition, which is on premises. And the business critical is equivalent to the enterprise edition of SQL Server. So moving on, so in the general purpose service tier, you deploy a single instance when you deploy a SQL managed instance, whether it's through Portal or CLI or Azure Data Studio, you only get one replica. In the event that a pod crashes, so in Kubernetes, you have your nodes, then you have your pods that run on these nodes, and each of these pods runs one or more containers. So the SQL instance also runs as a container in one of these pods. And pod crashing, pods movement is a common occurrence in the Kubernetes cluster. So in the event when a pod crashes, Kubernetes will recognize this event and it will try to spin up the pod on the same node. It will try to restart it and all. If the node has issues or if there is capacity issues on that node, it'll try to go find another node where there is enough compute and capacity, whatever you configured for the SQL instance. It'll create a new pod. It does the networking stuff. It attaches the storage from this failed pod to this new pod. It'll bring the pod online. And if you deployed it as a load balancer, if you recollect in session 1, when you deployed the SQL MI, one of the options for service type was either load balancer or node port. If you deployed it as a load balancer, the IP address will likely not change. The listener will just point to this new pod, whichever node it is running on. And your applications will simply have to reconnect and they will be connected to this new pod, which is running on a different node. Now, all this orchestration by Kubernetes can take some time. It could be a few seconds, it could be a few minutes. It depends on how much activity there is going on the cluster, how much compute capacity you have readily available at that point of time. So there are some factors that determine your availability, right? And all of this is potential downtime for your applications. And this is a variable part of it. You don't know if it's going to be like 5 seconds or 5 minutes, right? So this service tier, the general purpose service tier, is a good fit for low to medium critical applications such as reporting workloads or internal applications where a few minutes of downtime is acceptable. Um, Moving on, so now let's talk about the high availability feature or how that works in the business critical service tier. Okay, so in this service tier, when you deploy the SQL MI, you have the option to deploy it in 1, 2, or 3 replicas. Again, if you recollect, when we deployed it from the portal, you have the service tiers that you select first. When you select business critical service tier under high availability, uh, you will see 3 options: 1, 2, and 3 replicas, right? So we will talk about in this service tier. We will talk about the one replica model later. It's more applicable for DR scenarios. So typically, it's either 2 replicas or 3 replicas. So then you have your primary replica, and then you have your either 1 or 2 secondary replicas, and each replica is running in its own pod and has its own storage, own capacity in terms of memory, has its own CPU allocation. So there's nothing shared between these pods. Each of these is independent. Most likely, they are also running on different nodes for better availability. So during the deployment itself, the replicas have contained availability group as part of the deployment between these replicas. And data is synchronously replicated across these replicas. For example, in this diagram that I have on the slide, I have a 3 replica BC instance. This means there is a primary replica, like the one in the middle, which is green colored. And then I have 2 secondary replicas, and data is synchronously replicated between these 2 replicas. There is also a listener service or listener endpoint for the entire 3 replica deployment, and your application only connects to the listener endpoint. So if there is a failover between these two, your applications don't have to connect to a new IP address. You can use the same IP address. So let's consider the same scenario that we talked earlier, where if one of the pods has crashed, right? For whatever reasons, right? So there is also a component or a pod in this case called HA orchestrator pod. In session 1, when we did a deployment, I went to command line and I ran a command called kubectl get pods. And I think if you remember, one of the pods we noticed was the SQL MI1-HA. That is the orchestrator pod that is deployed as part of the contained AG setup. This orchestrator pod's job is to keep a tab on the health of the replicas. There is a config map, and the config map has the matrix of how many replicas you have, which one is the primary, which ones are the secondary. And this orchestrator's job is to update that config map, keep it up to date on whichever is the primary. So when the orchestrator recognizes that the primary instance is down, it promotes one of the 2 secondaries to become the new primary. The listener endpoint always points to whichever is the primary, so that doesn't change. So which means your applications get automatically redirected to this new primary. While this is happening, the rest of the Kubernetes orchestration will still continue to happen, as in the previous case, right? So Kubernetes also recognizes that one of the pods is down, so it does what it needs to do. It'll try to bring the pod back online on the same node. If that doesn't work, it'll go and find a different node that has the required compute and capacity available. It brings the pod online, attaches the storage, and it does all that stuff, right? When the pod is available, up and running and online, that replica is added back into the availability group, and data is synchronized to bring it up to speed with whatever changes that have happened while that pod was down. So in this case, let's say the pod is back up. So your end state is that it's back to your original 3 replica setup, right, where all the pods are up and running. As you can see in the slide, the difference is that your primary has moved to one of the secondaries. So in this model, the actual downtime for the applications is literally the time to failover, which is 1 to 2 or 3 seconds. It's very minimal. The applications are shielded from all the Kubernetes orchestration that happens in the backend, where it's trying to create a new pod, spin up the services, and all that. That can happen in the background asynchronously, but your applications don't have to see any of that. They just continue to read and write to this new primary while that orchestration is happening in the backend. So this model is recommended for all business critical applications where downtime is not acceptable. So as you can see, we have differentiated capabilities for high availability between general purpose and business critical service tiers. So I think it is demo time. So in the session 1, we did a demo of deploying SQL managed instance through Portal. In this case, we will use Azure Data Studio. Let me switch over to my demo instance. Okay, so I'm connected to my demo instance. First, I'm going to run a command called kubectl get SQL mi -A. This will give me a list of all the SQL instances on this cluster. So as you can see, I have one SQL instance already, which we deployed in session 1, SQL mi1, and it's in the namespace called DPS 2022NS. And you can see that we have 3 replicas, and there is a listener endpoint that I was talking about earlier. So your applications will connect to this listener endpoint. So we're going to use Azure Data Studio to deploy a second instance. So I was able to resolve my subscription issues that we saw earlier in session 1. So in this case, you can see I connected to that SQL instance, and we ran the availability replicas query earlier. So what I'll do is go into these 3 dots here and click on new deployment, and you will see the same screen again. So hybrid is one category where I can filter down and see that I have SQL managed instance, data controller, and Postgres. So I'm going to choose SQL managed instance and click select. And there are 2 types of SQL managed instance, one in Azure, the one outside of Azure, which is the Azure Arc. So that's the one we want to select. So you see that there is an error message. It says no Azure Arc controllers are currently connected. So please run the command connect to existing Azure controller and try again. So what it's saying is that before you deploy a SQL managed instance, you need to have a data controller and you need to have connected to it. So I'm going to cancel out of this screen. And remember, we talked about extensions in Azure Data Studio. So if you go to the extensions, there is an extension called Azure Arc that you have to install. So I already have that extension installed. It's usually minimized here, so you can click on this, it'll open up. I need to click on connect controller, so connect to the data controller. So in this case, I need to provide the name of the namespace where my data controller is. If I don't know that, I can simply go to my CLI. I can run any of these commands, either get SQL mi, or I can also run kubectl get data controllers -A, and I'll get the name of the data controller and the namespace it's installed in. So back in the Azure Data Studio, all it needs is the name of the namespace, which is DPS 2022NS in this case. And it's going to attempt to read from my kube.config file in the default location. And in my config file, I have previously connected to 4 different clusters. So it's showing me that I can connect to any of those. It defaults to the latest one that I've connected. In this case, DPS 2022 AKS. This is the cluster that we connected to. So I'll leave it as is, and I can optionally give it a display name, which will just show up here. So right now I have all the information, required information. I'm going to click on connect. It will use my kubeconfig file, read the cluster context. It'll read the credentials from that config file. It'll go and connect to that Kubernetes cluster wherever it is, Azure, outside Azure, and then it'll bring back some information. So in this case, so it's connected to my cluster, to my data controller. So I can click on this. It will go run some AZ commands to bring back the SQL instances, Postgres instances I have. So right now it recognized that I have a SQL mi1 instance. I can also right click on this data controller and click on manage. So I'll see a dashboard view. So it will tell me all the metadata about my data controller, what's the name, what region it's deployed in, what's the namespace, resource group, and it also tells me whatever SQL and Postgres instances I have deployed so far onto that data controller. So right now I have one. We'll install a second one. You can also use the upgrade management to upgrade your data controller. We are already on the latest version, so there is no newer version to upgrade. So from here, I can also click on this new instance to deploy the SQL managed instance, or I can go back to the same view, new deployment, and select SQL managed instance, click on select. I can do the same process again. I have to accept the license terms, and it will do a quick check if I have the required client tools like kubectl and Azure CLI. It checks the version, makes sure we have the minimum version. Click on next. So right now it knows the data controller context. So it already got that from my connection. So I'm going to create SQL MI2 in this case. I'm going to provide some user SQL authentication. SQL admin, let's say. And I'm going to select either business critical or general purpose. Again, I'll select business critical in this case. I'm going to pick development only. So as you can see, again, just like in Portal, you have the option to deploy 1, 2, or 3 replicas. So in this case, just for a change, I'm going to pick 2 replicas. I'm not sure if I have enough CPU and memory to support 3 replicas because I already have 3 from the previous installation. So I'll just pick 2 for now. You can also select how many readable secondary replicas you want. Because there's only 2 replicas, the option is 1. Also, how many synchronized writes you want to have across those replicas. The only other thing I will change is the data and logs will go to default. In this case, my default is based on the template that I used, which will be premium storage in Azure. The only thing I will change here is the backups storage class. I'm going to use Azure file because Azure file supports read write many. The premium storage does not support that. So you can see it is read write many capable. I think memory limit, I'm going to limit it to 2. Course limit, I'm going to limit it to 2 as I don't have enough capacity there. Cost, right now it shows 0 because I selected development option. The other option it shows here is the backup retention policy. In this case, the default is 7. You can go anywhere from 0 to 35. 0 means don't take any backups. This is just like what you have in Azure for point-in-time restore backups. Default is 7 days. I'll leave it at that. So when I click on deploy, it'll give me a notebook with all the information, and I can click on run all to start deploying the SQL managed instance. So while the deployment is happening, I can also go and verify or check the status of that. I can run the same command get SQL MI, and I should see a second instance that should start showing up quickly. Let me see if there's any errors. It's still running the first, it's doing some prerequisite checks. So we'll come back to the deployment and we'll proceed with the presentation. All right. Point in time restore. So this is the next feature we'll talk about. So first, I want to point out that this feature, the point-in-time restore feature, is available in both the service tiers, general purpose and business critical. There is no differentiation here. Point-in-time restore for general purpose. So while the capability is same in both, the way it functions is slightly different between GP and the business critical. So first, let's talk about the general purpose one. So in general purpose, you only have a single replica, and backups are automatically performed on both user databases and system databases. And the automatic backups service, it's on by default. There is no additional configuration needed other than providing the name of the storage class where the backups will be stored, make sure it's read write many capable, and also the retention settings. Default is 7, so you don't have to change anything if you don't want to. The storage class for backups, again, just to point out, has to be read write many capable. I think that's simple as that. So let's move on to the next service tier, which is the business critical service tier. So in the business critical service tier, it's slightly different. The backups happen on the primary replica. So in this case, you have multiple replicas, as you can see. You either have 2 or 3 replicas. The backups happen on the primary. So if there is a failover, and like remember we talked about the high availability scenario where pod crashes and your instance moves to one of the secondaries, when that happens, your backups will move with the primary to whichever pod is the primary, right? So other than this part, the rest of the implementation concepts is similar for both the service tiers. So demo time again. So we'll do a point in time restore from Azure Data Studio. We can also check the Azure CLI. Portal does not have the restore capability yet. It's work in progress. So let's switch over to my demo and check on the point in time restore. Okay, so I'm connected to my demo machine and using my Azure Data Studio. So in this case, you're looking at the data controller overview dashboard page. So I'm going to click on SQL MI and click on manage. So it'll bring up the SQL dashboard. It'll list the databases that are currently on the SQL instance, system databases. And so in session demo, between the two demos, I had some time to go and download and restore the AdventureWorks database because you need some time for the backups to kick in. So I was able to do that between the two sessions. So what I'll do is click on backups, and this backups page will show me a list of all the user databases and system databases, and you will see that there is a restore column at the end. For every user database, it will show you a earliest point in time and the latest point in time to which you can restore to. So you'll see the entire window. You don't see that for the system databases because you have to do that manually. We don't provide a GUI to do that. So you can also change your retention policy for some of these databases from here. So in this case, I'm going to use this timestamp to restore to the latest point in time. I can also click on this restore button here, and this will pull up a window on the right where I can provide the information. So subscription information, resource group, it's all grayed out. You can't change any of that. So today, you can only restore to the same instance. You cannot restore across instances, but you can restore to the same instance with a new database name. So the source is AdventureWorks 2019 database. I can give a new name to the destination database. The instance is the same thing. Restore point, what is the time to which I want to restore to? So I have the earliest point in time, I have the latest point in time, and I can give a time between these two. I can also leave it blank, which will restore it to the latest point in time. I also want to show you a CLI way of doing the same thing. So if I go to my command line, one thing I want to point out is the restore command is under SQL MIDB. What I mean by that is, so there is a AZ SQL MI command group. So under the SQL command group, you have mi-arc, you have MIDB and MIDB-arc. So if you're interacting with any of the ARC resources and you're talking to the instance level, you go into the mi-arc subgroup. And if you're talking to the database level, you go to the db-arc. Restore is a database level operation. So we are going to be working at the MIDB-arc level. So I'll do AZ SQL MIDB-arc-edge, and I can see all the commands that are under that. So today, the only option right now is to restore. So I'll do a restore command through CLI. So I've pre-prepared the command luckily, so we don't have to sit and type all of it. So I have the SQL MIDB-arc restore. I need to provide the name of the instance, the name of the source database, in this case, AdventureWorks 2019. What is the name for the destination database? I'm going to call it 2022, just like that. And the time to which I want to restore to. So if I don't know the time, I can just provide some random time. And I also need to provide the namespace, in this case, --k, its namespace, and the name of the namespace where the SQL instance is. And I also have to tell you to use k8s. The reason for having this use k8s flag is that AZ command has been designed and built to talk to Azure ARM APIs. In this case, we are forcing it to use the Kubernetes APIs. So that's why this use k8s means. So this flag called --dry run means that it will go and evaluate this entire command. It will go check the source database name, the timestamp that you provided, the instance to connect to, and it will validate if that operation is going to successfully complete or not. So if I run this command, it will do all that math. It will figure out the first full backup, the latest differential, and all this sequence, all the transactional log backups that are needed to restore to this point in time, and it will come back with a message that says successful or not. So in this case, it says dry run completed. If you provided the name of the database wrong or the time wrong, you will see a message appropriately in this one. So I can rerun the same command and remove the dry run, and this should restore the database into AdventureWorks 2022. So we can leave this on. We can come back and check this one. In parallel, we can also check the SQLMI deployment that we started earlier. So I'll run kubectl get SQLMI dash capital A. So you see that the SQLMI2 that we just deployed 10 minutes ago with 2 replicas is already done and ready to go. So we'll leave this one on. We'll come back to the presentation. Okay. So moving on to disaster recovery. So this is the next feature we'll talk about is the disaster recovery, or the DR is achieved through Azure Instance Failover Groups. This is similar to Azure SQLMI concept. So I want to point out again that this capability is available in both the service tiers, so there is no differentiation here. Moving to the next slide. So the instance failover groups is just a term, but it's the same thing as distributed availability groups that has already been available in SQL Server since 2016 or 2017, I think. So we took the same feature and did some additional work to make it work on Kubernetes, because the original feature was designed to, or built and designed to work on Windows, right? So in Kubernetes, there is a custom resource that gets created on both the sites, the primary and the secondary sites. In this diagram, what I'm showing you is how the DR setup looks like when you have a 3 replica business critical service tier setup in the primary data center and another similar 3 replica business critical service tier setup in the secondary data center. And the instance failover groups is configured between the primary data center and the primary replica in the secondary data center. Now, because these 2 business critical service tiers, the instances are business critical service tiers, each data center has a local high availability. So when data is written from the primary replica in the primary instance to the primary replica in the secondary data center, the local secondaries get automatically updated with this new data. So this is another diagram representing the same feature. I just mentioned the distributed availability group is the actual SQL Server feature that's powering the failover groups. We are calling it Azure failover groups to align with the terminology in Azure SQLMI. And this is just another diagram representing the same feature. So time to demo again. So we'll do a demo of how to create the distributed availability group or the instance failure group in CLI. So we don't have that in Azure Data Studio or Portal yet. It's work in progress. So we're going to use a CLI to create the instance failure groups. I'm going to switch to the demo machine again. Okay, so let me walk you through setting up the Azure instance failover groups. Let me show you where the command group is. So under Azure SQL command group, remember we looked at the mi-arc, midb, and midb-arc. So SQLMI already has an existing command group called instance failover group. This is used to manage the Azure SQLMI instance failover groups. For arc, we are using the same naming pattern and we are just appending -arc at the end. So you'll see the pattern is that if you're talking to Azure equivalent resources, you will have the Azure equivalent name, and the arc equivalent name for that will be just the arc at the end. So for MI, it's going to be mi-arc. For DB, it's going to be midb-arc. So in this case, we will use this failover group. And let me show you what else is in that. So under that, you can do a create your failover groups. You can delete it, you can show, you can describe it, and you can also update the failover groups. So we're going to use the create to create the failover groups. And setting up DR between two SQL instances is a very simple 2 to 3 step process. So I have a notepad with the actual steps. This is as simple as it can get. So first what we need to do is we need to get the mirroring certificates for each of the instances for both primary and secondary. It'll create a certificate file, and you can point to a folder where those files can be saved. And once you have the mirroring certificate files created for each of these instances, so on the primary, you create the failover group and pass in certain commands and parameters, right? So you need to use the create, of course. There is a shared name that you have to provide. This is the shared name that will join the primary and the secondary. And you need to provide a name for the custom resource. So if I look at my custom resources, for example, kubectl get crd. So these are all the custom resource definitions. One of those definitions will be the failover groups. So if I run kubectl get, for example, if I do get failover groups dash capital A, it should give me a list of all the failover groups that I've created. Now I can create multiple failover groups. Like I can have one primary, one geosecondary, and second geosecondary, third geosecondary. So I can have multiple geosecondary sites. So I will see a list of all of them. This is a standard kubectl command. Kubectl get the name of the resource you want to get, and dash capital A means get all the resources. So we use the same command for SQL, for example. Kubectl get SQL managed instances. I could run the same command with this. For example, if I run get SQL managed instances, I'll see a list of all the SQL MI. So the shortcut for that was kubectl get SQL MI. And the shortcut for failover groups is fog dash capital A. So it should say no resources found because we haven't created any failover groups yet. So we'll go and create a failover group, and the name of the CR. So when you create a failover group, the name of the CR that gets created has to have a name, the custom resource. So that's what this dash dash name is. And then you provide the primary instance. Who's the primary instance? What is the role for that instance? Who's the partner instance? The name of that partner instance, and the URL for that partner instance. So from primary, you're saying this is my primary and this is my partner instance. This is the URL for that, and the certificate to connect to that partner instance is in this certain location. And then I'm also specifying what namespace this primary is in, and also I'm saying use K8s. Again, remember AZ was designed to talk to Azure. We are kind of twisting it to use Kubernetes APIs. So this dash dash use K8s flag means it's going to talk to the Kubernetes APIs. We do the same thing for on the secondary, but we flip the parameters. So here you still have the same shared name, which should match with what you have on the primary. In this case, the name will be the name of the secondary, the custom resource for the secondary site. The name of the instance will be instance2, which is your secondary instance. Let me change this to 2. In this case, the role of that instance is secondary, and the partner for that is the primary. So I'm going to provide the partner instance name, which is the SQL MI1, and the partner mirroring URL. I'll show you how to get the URL in just a minute. And then the folder where I can access the certificate file to go and talk to the partner instance. Again, the name of the namespace is the DPS. For the purposes of this demo, I'm going to use the two SQL instances that we created during the demos. We had a SQL MI1 and SQL MI2. I'm going to set up a DR or failover groups between these two instances. And since they are both in the same namespace, I just have the same namespace here. But ideally, in the actual scenario, you have a primary cluster, you have a secondary cluster in a different data center, and likely that they will have different namespaces and different instances. So to get the mirroring certificate file, you can run kubectl describe my object, which is SQL MI, and the name of the object, SQL MI1, and what namespace it is in. So I'll get a bunch of output, name of the instance, all the settings, the memory, CPU, collision levels, time zones, access modes for storage classes. So one of the data here is the mirroring endpoint. I think it's here. So this is the mirroring endpoint that you need to copy out of here. So there is also the primary endpoint and secondary endpoint. There's a mirroring certificate file. And you can also see the high availability. If you remember, SQL MI1 had 3 replicas, SQL MI1-0, 1, and 2. I can also see that MI1-0 is the primary and the other two are secondary. And I can see that my the health of my availability group is in healthy state. You can see that it says synchronization state is healthy for all of them, right? So what I've done is I have already copied the mirroring endpoints from here into my notepad. So first I'm going to create the certificate file for the primary, then I'll create the certificate file for the secondary. And it should create a file in this folder. So you see it just got created. I'm going to run the second command to create the certificate file for the second instance. It's going to the same SQL search folder. I'm going to call it SQLMI2.pem. So if I go back to that folder, I should see a second file called SQLMI2.pem. So I have the files now. So what I'll do is the next command. On the primary, I'm going to run the failover group create command. This should take like a minute or less. So it should be pretty quick. The instance one is ready. So if I run the same command, remember earlier, kubectl get fog dash capital A, I should see one record. So I have an instance of my fog called instance1 CR. This is the name of the custom resource. The status is succeeded and it's in the namespace DP 2022. So I can also do a describe on it. Describe fog instance1 CR dash n, and I should see the information about the custom resource itself. So in this case, for example, if I scroll down, it's telling me who is my partner, what's the name of that instance, the URL for that partner instance, the role of this CR is that it's primary, the shared name that we created, the source instance, and health status and all that stuff. So I'm going to go and create my second. Ideally, I would run this command on the second cluster, on the geo secondary side. In this case, they are both on the same cluster, so I'm going to just run this on the same here. So it should go and create the fog for the second one as well. So let me copy the file name properly. I think I may have made a mistake in the just a second. Okay, so I had a typo in my path to the certificate file, so I fixed that and it just created the second CR as well. So I can run the same command, kubectl get fog dash capital A. I should see two CRs, one for the primary, one for the secondary. Now again, in the real scenario, you will only see one on the primary. Your secondary site will have the second CR. So if I do a describe on the second one, I'll see the pointer back to the primary. So right now I have my instance failover groups set up between the two. It's as simple as that. So if I run a kubectl describe SQL MI dash capital A, I should also see the DR information. On this one. Let's check that on the Azure Data Studio actually. I have my query still here. Let me bring up some queries to check. If I run the same command, let me connect to it. Okay, so I'm connected to my SQL instance, in this case the primary, and I run a command sys dot select star from sys dot availability groups. If you recollect, in the session one, In session one, if you remember, we ran the same command, select star from sys.availability groups, and we only had one record, which is the contained AG record. So now after creating the instance failover group, which is the distributed availability group, there is a second record called myfog that got added. I don't think there is any useful additional information. So another command we can run is availability underscore. So the command to run is the select star from sys.dm hadr availability replica states. So when I run this command, I get 5 records. One record for each replica. So if you remember, my primary instance had 3 replicas and my secondary instance had 2 replicas. So 3 plus 2 is 5. So I'm going to see 5 replicas and the status for each of them. So for example, so I have 2 primaries, one for each site, and the other 2 are secondaries, right? On the primary side, I have 1 primary and 2 secondaries, which are the first 3 rows, and on the secondary side, I have 1 primary and 1 secondary. I can also see the status. They're all online. At least the primaries are online. They're connected, and there is a health status that says healthy or unhealthy. So this is what you can use to verify your information. You can also use SQL Management Studio to connect to these instances and these endpoints. For example, if you run the kubectl get SQL MI capital A, you will get the listener endpoints. So you can connect to these endpoints from SSMS. You can go to the high availability nodes, and you can see the primary, the secondary. You can see the dashboards for your AG. So all of that information should continue to work. So moving on with the presentation here, let's go to the next topic. In this case, it's the security. My windows here. All right. So in terms of security, there's multiple facets when we talk about security, right? First is the authentication and authorization mechanism. We support both SQL and AD authentication. Next is encryption. We support transparent data encryption for data at rest and TLS support for encrypting your connections. And then finally, the least privilege access setup. Root level access is generally considered not secure. It requires higher privileges and exposes higher security surface area. So we deploy all our container images in non-root level. So we are only requiring minimum permissions to run. So as you can see, we run our services with minimum permissions. Your connections are encrypted and your data is also encrypted, both at rest and in transit. And this provides the end-to-end security. The next slide has encryption. So we talked about encryption. One thing to point out here is that we support both customer managed and system managed keys, which means you can bring your own certificates or you can use the system managed ones. The next topic is upgrades. Let's move to the next slide. So in session one, if you remember, one of the first things I mentioned about Arc Data Services is the evergreen policy or evergreen version, similar to what you get with Azure SQL MI. So what this means is there is no support cycle or end of support cycle to worry about. You don't have to worry about major upgrades every 5 to 10 years. You get monthly releases that have both security fixes and bug fixes as part of the same release. And our releases are aligned to Patch Tuesdays, which is like the second Tuesday of every month. Now, depending on how you deployed your SQL instance, whether it's general purpose or business critical, the upgrade process might be slightly different. So let's talk about that. So the way it works is first you go and download the released container images from our Microsoft Container Registry, right? You can either upgrade directly from MCR, like point your repository to MCR, or you can download those images, put them into your local repository. If you want to scan them for any viruses, you can do that. And you can point your upgrade to that local repository. Then you run the update steps. This includes updating the data controller first, and then each of the SQLMI instances. When you upgrade the data controller, the image gets updated with the new container image, and the controller pod restarts maybe a couple of times. This doesn't impact any of your applications connecting to your SQL instances. So your DC can be upgraded anytime. Once you're done with the data controller, then you upgrade the SQL instances or Postgres instances. It's the same process. The images get updated with the new images. And in the general purpose, if you remember, there is only one replica. So when the pod restarts with the new image, there is a small downtime for a few seconds. Right? In the business critical model, where there are multiple replicas, the upgrade works differently. So when you run the upgrade on the SQL instance, if there are multiple replicas, we automatically recognize that, and we do a rolling upgrade. You're probably familiar with this in the contained AG or in the AG setup, right? So we upgrade the secondaries first, both one or two, however many secondaries we have, we upgrade those first. Then we fail over the primary to one of those upgraded secondaries, and then we upgrade the primary, and then the old primary or the is updated, restarted, and then it's added back to the AG setup, right? So in this case, in the business critical, it's almost near zero downtime. It's just the failover part, right? And then there's a few additional knobs we have added to make this upgrade process simpler. For example, if you have, let's say, 20 or 50 SQL instances, you cannot be going to every SQL instance and run the upgrade command, right? So you want to do this at scale and automate it. So there is a setting called -- desired version for each SQL instance that you can set. You can set it to a specific instance, to a specific version, or you can set it to auto. So what this means is, when the data controller is upgraded, it will go and check if there are any SQL instances that have this property set to auto, and it will automatically upgrade each of those instances. So you can also mix and match. For example, let's say you have 20 SQL instances, and let's say 5 of them are business critical, important to you. The others are not that critical. So you can set the others to auto upgrade, and you can manually upgrade the important ones at your own scheduled downtime, and leave the others to auto upgrade. So another knob here is the maintenance windows. This is the same concept that's already available in Azure. You can preset the maintenance schedule with start and end times, and the data controller will, and SQLMIs, all of them will upgrade within this time. And if we reach the end of time, we'll just pick it up in the next maintenance window. So depending on the length of the schedule, we'll try to upgrade as many as we can and try to stay within the schedule. So moving on, the next topic is the monitoring. So if you remember, again, one of the built-in features is the monitoring, built-in monitoring. And we have rich dashboards, Grafana dashboards that power the metrics and logs. Grafana is for metrics and Kibana is for logs. So in this screen, what you're looking at is a Grafana dashboard. As you can see, pretty much most of the common metrics that any SQL DBA would care are already captured out of the box. You can also customize these reports however you want. You can configure alerts from this dashboard to get notified when certain thresholds are reached, CPU too high, disk too high, whatever metrics you care about, right? Optionally, you can also upgrade or upload your logs and metrics to Azure, Azure Monitor, and Azure Log Analytics, and you can get notified from there as well. And the dashboard for this is in, if you remember, we did a kubectl describe SQLMI. So one of the properties in there is the logs dashboard and metrics dashboard. So you can copy the URL into a browser and connect from there. You can also go to Azure Data Studio. If you go to the overview page for your SQL managed instance, you can see the logs and metrics dashboard over there. For example, if I switch to my demo machine, I can go to the Azure Data Studio here. I go to the dashboard, so overview page, and you can see the Grafana and Kibana dashboards that I have here. Okay, so moving on, I think we're getting close to the time. So this dashboard is the logs dashboard. This is the Kibana dashboard. Again, you can configure custom alerts. You can even customize the dashboard. You can set additional filters. You can create new visualizations. You can do whatever you want with these dashboards. So the final topic that I have today is the roadmap. We talked about the roadmap in the first session, but we'll go over that again. So everything we talked or discussed today is publicly available. GA services. You can run your production workloads and get enterprise level support for those services. Some Azure Arc services are still in preview mode. If you're interested in any of those, for example, Azure Arc PostgreSQL is in preview mode. There are some services under the Azure Arc enabled infrastructure model that are in preview mode. So you can take a look at this. The other services focusing on just the data services, again, pretty much all the features, again, we talked about HADR, backup restore, all these dashboards, contained AG, failover groups, all of these features are generally available. The only things that are in preview is the AD authentication, both customer managed and system managed, and the Arc enabled Postgres service is also in preview mode. With that, I also have some resources. You can go check out any of these. There's videos, there's blogs, there's documentation, there is customer stories, how customers have used our services. So all good stuff is already here. So with that, thank you for attending these sessions. Again, this is part two topic. We have two sessions on this topic where I covered an overview in the first session, and we did a deep dive and a lot of demos in the second session. Thank you for attending, and you all have a fantastic rest of the conference.